I thought most of you could use one more example of taking the zeros and writing a polynomial with those zeros. So here is a second example of that process. So it says write a polynomial of degree 4 in standard form with zeros of 1, having a multiplicity of 2, and negative 4 plus I. Okay, so remember that the first thing that we want to do is take that information and find all the zeros, right? So our zeros that are given are 1, which of course occurs twice, and negative 4 plus I. Now remember that our conjugate pairs theorem, right, tells us that we will also have negative 4 minus I. Remember that the conjugate pairs, because there's a little bit of negative signs there, right? The conjugate pairs, it's A plus BI and A minus BI. So notice that it is the I term, the imaginary portion of the number, that is positive and negative, not the real part of it, the A part. Okay, so the negative 4 stays negative 4. So in factored form, we have f of x, for example, and then our first zero is 1, so that's x minus 1. And remember, it did say multiplicity 2, so recall, as we learned before, that that means that that factor is squared, x minus 1 squared. And then we have two zeros here, x minus negative 4 plus I, and x minus negative 4 minus I. I personally would write it out this way to make sure all the negative signs get distributed correctly, right? Even though I'm the math teacher, I would still write these out and just double check my work there. Okay, so this could be factored form. We can also like simplify it a little bit. So we have the x minus 1 squared. Now to deal with those negative signs, we have x plus 4 and then minus I, right? That's because we are distributing this negative sign to here and to here. And then in the second term, we have x plus 4 plus I, right? Because we are multiplying here and here. Okay, so just like before, I recommend that we start by multiplying out this trinomial times this trinomial, the complex numbers first. This x minus 1 squared, we are also going to have to multiply that part out. So you know, that's but that let's tackle that second. Okay, so you can just multiply all of the terms together and then just watch what cancels, and just be careful since it is you know, 3 terms by 3 terms. There's going to be a lot of terms involved. All right, so I'm going to move it over here so I have enough space to write. Okay, so that's just this part still just copied down. The next part, I'm going to do this x times all 3 of the terms in the second polynomial, so in the trinomial. So x times x being x squared, this first x times the 4 being plus 4x, then finally x times I is xi. All right, now go to the middle term here, this 4, and multiply it by all 3 terms in the next, in the trinomial. So 4 times x is plus 4x. 4 times 4 is plus 16. 4 times I is plus 4i. Okay, then finally, so you'll notice that this is already 6 terms and there's going to be 3 more. So there's going to be 9 terms total if you're multiplying 3 by 3. All right, our last term is this negative I, multiply it by all 3 terms. So that's minus I times x. Xi and Ix are the same thing, so order, it doesn't matter there. Negative I times 4 would be minus 4i. And finally, negative I times positive I would be minus I squared. Okay, so there's all 9 terms. I think that we should kind of use some underlines and stuff to group all of the like terms, right? So we only have one x squared term, but I'm thinking we have a 4x here and a 4x there. And I think those are the only constant and an x term, okay? We also have xi, so let's put 2 underlines under xi's, and then we have a minus xi. Hey, that's good, right? We have a 16, and that there's the only one constant there, only one number there. We have a plus 4i. I'm going to put a little box around that one. And we have a minus 4i, right? So you can hopefully see that some of these things are going to cancel out. And then we have this minus I squared. Do you remember from the last example what I squared equals? I hope so. I squared equals the number -1. Not negative I, just -1, the actual number -1. So this number is minus -1. So this is going to be +1 right there. Okay, so technically the 16 and the 1 are going to be like terms. Okay, so let's write that all out. Let's see. I guess I'll use the blue to say I'm combining those like terms. All right, so we still have x squared. We have 4x. And where's the other 4x? Oh, right there, 4x. So plus 8x. Now, plus xi minus xi cancel. And plus 4i minus 4i cancel. And then we have 16 plus 1, so plus 17. Isn't that magical, right? So many things canceled each other out, added and subtracted to 0. So yay, we are left with just a nice little trinomial with all real numbers. If you do this right, you'll never have an I in these terms, okay? You'll never have an I. Of course, all I squareds are -1, so you'll never have any i's in there. All right, we are not finished with the problem. We still have to multiply out x minus 1 squared. So for that part, let's think about the fact that x minus 1 squared is actually x minus 1 times x minus 1. Okay, in order to get this right, we have to FOIL this term as well. Okay, we still have our new, okay, but this part's pretty easy to FOIL out when we know that. So that is x times x squared, minus x and minus 1x there. So minus 2x, and then -1 times -1 plus 1. Okay, so that is these two terms multiplied out. And now we're still needing to multiply x squared plus 8x plus 17 times those. So I need a little more space. No worries. Our final part is to multiply this trinomial here by this trinomial here. So let's see, I think I need another color. This is going to be the prettiest problem ever. Okay, so all of these, remember it's a 3 times a 3, so there will be 9 terms total. Okay, and these may not cancel out as much. They will still have some like terms to combine though. All right, so our first term is x squared times x squared, which is x to the 4th. Now we're going to take this x squared here and multiply it by this one, and this one. We already did that one. We're multiplying by 8x. So x squared times 8x is plus 8x cubed. X squared times positive 17 is plus 17x squared. Okay, now we're on to the second part. So we have to do -2x times each of these terms. Okay, so -2x times x squared is -2x cubed. Then -2x times positive 8x, -16x squared. And then -2x times 17 looks like -34x. Finally, we have 1 times each of these terms. So x squared plus 8x plus 17, because they're all times 1. Okay, let's do the same thing we did before, just to combine our like terms, because we need to make sure we catch them all. So there's just those 2 cubic terms. Then there's a couple squared terms there, that one, and that one. And then it looks like we've got, I can do just a different color there, negative 34x and positive 8x. And then the x to the fourth and the constant term, there were no like terms for those. Okay, so our final answer looks like x to the fourth, and then we have plus 8x cubed minus 2x cubed, so plus 6x cubed. Then we have 17x squared minus 16x squared, so that's only 1x squared, plus another x squared, so that's 2x squared. Let's see, our next terms are the negative 34x and plus 8x. So that looks to me like negative 26x and then plus 17. Okay, so that was equal to our f of x and our final answer. And remember that that is one polynomial that will have those four zeros. We do not know if, the coefficients, because that could change the final answer as well. But this is one polynomial.